In this section, I want to discuss refactoring code. So refactoring is not specific to functions, but it is a very important part of programming, and it's just a good time to bring it up. So what does refactoring mean? Well, it means to rewrite code so that the overall structure and design is improved. Refactoring does not change the functionality, so that remains the same. This is not adding new features or expanding your program. It's literally rewriting the same code that you already have in a different manner so that it performs better. There's many benefits to refactoring. I just listed a few over here. You can make the code more readable. You can make it easier to find and avoid bugs. You can make it easier to maintain. This means for yourself, for others to use, for others to use your code in other programs. There's just a lot of benefits to refactoring. It's basically this giant reorganization, restructuring of the code so that it just works better and its overall quality is improved. So there are many examples you can think of in the real world, such as reorganizing items in your house or office for ease of use. You can think of when you first buy something for your office or your house, you bring it in, you may not have the perfect place for it. After a while, you think of a good place for it, and it just your whole house and office or whatever just functions better and just easier to use and get around. So that is what refactoring is. What we're going to do right now is refactor some old code, the trivia game, and this is actually something common that you'll do is you'll write some code that's not like in a function, and then you'll realize that, okay, I can just place this code inside of a function and then just make that function very good at that one specific task. What I want you to do now is flip over to VS Code, open up the Python fundamentals directory, go into the user defined functions section, and then click on trivia function.py. So this is going to be our original one that we declared in looping. So if you go back to looping, it's the one over here. It's under trivia loop solution.py. It's that copy. I just copied and pasted that over here. So what I'm going to do now is refactor this code so that it uses functions in it. So let me just zoom in a little bit and move that over to the side. All right, so I'm just going to edit this file so that it uses functions. It's a pretty short file. Let's review it real quick. So we define set the score to 0, missed questions, empty list. We have a welcome message. Then we have questions and answers for each one of the 5 trivia questions. We're going to print the welcome message. Then we're going to create lists of those strings for questions and answers, get the number of questions like that. And then we're just going to loop through. We're going to go through each question one at a time. We're going to print out the question, get the user answer, check that the answer, if it matches, the user answer matches our answer, so one of these. Then it will give the user credit, increase the score, and print out a message. So it'll do that for all 5. It'll tell the user if it does not score, and it'll append the question number to this missed questions list. Once it iterates through all 5, it'll go to the end of the game and just print out a message either way. So either they got a perfect score or they did not, and then the questions that were missed. Okay, so what I want to do here is I'm going to refactor this. This is already a fairly short program, but I wanted to show one example of some refactoring that you could do. So let's take a look at what's going on in our loop over here. So there's actually quite a lot going on. We could say there's like maybe two independent tasks. One task is just to ask the question and get a response. So that is one of them. Another task is to just check whether the answer is correct. So let's go ahead, and what we'll do here is we'll create a function called ask question, and inside of it, what I'm going to do is I'm just going to copy and paste this asking of the question over here like this. And so I have a function over here. This function, its sole purpose is to ask the question, and it'll actually return the response. So it's going to get this answer, and I'm going to return it, which means I need to ask this question right here. So excuse me, this needs to ask question like this. Now, if you notice here, it's using the variable I, so it needs to be passed in I, or else it won't know what to get. So I needs to be a variable. Okay, so I've refactored this logic over here, the ask question logic, to its own function. All right, so let's make sure that our program still works. So Python, and then actually I need a CD into here, so I need to go into module 12, user defined functions, and then I can call Python trivia function dot py like this. And I'm just going to put in some stuff. Okay, it looks like it works. By the way, you can exit out of here by pressing Control C. So I just wanted to check that it worked real quick. It was able to ask the question, get that answer, and then it'll check the answer over here. Okay, so that is a refactoring of this. Now we're going to refactor this right here. So this is where we check this, check for the correct result. So we can just say check answer like this, and now I'm going to place all of this code inside of this function over here. And so again, for this, it is receiving, we have to look at the variables that it's using. We can't just use this function. We would like to. So say we want to update our score like this. So we're going to check the answer. All right, so this function needs to have access to the answer. So we need to pass it in the answer. That means it needs to have this answer parameter. It also uses I, so we're going to use I like this. It needs to update the score, so it needs to take in score. And it also needs to take in the missed question. So it needs to have access to this missed questions list like that. Okay, so I've named the parameters the same thing as the variables over here. And so that's how we can refactor that. So now our main body, our main loop over here that's doing the actual gameplay, you can see here, so the logic looks a little bit easier. You're going to ask the question, and then you're going to check the answer. And you're going to repeatedly do that. Okay, so let's go ahead and run this a few times, or just one time, excuse me, and just make sure. I'm going to put in some nothing. Okay, I didn't get that right. Let's get an answer correct. Okay, so we have an error over here. It says unsupported types for none type and int. So we have to see, all right, so what is going on? So after pausing the video and looking at this more closely, I realized my mistake. So in this function, I have no return statement. So whenever so we're in this loop. So after the first call of this function, so after when I is 0, it's going to return none. So score becomes none. So this is a big problem. Score can't become none. That's why it tries to add score when it gets it right, none to 10, and that's why we're getting this error. So I need to put return score over here. Otherwise, functions will return none. Okay, let's go ahead and save that, and then I'll run this again, and let's just get one right. So Saturn, okay, good, I got the score 10. Let's get another one right, 50. Our score is now 20, and so forth. I'll pause the game or exit out with Control C. Okay, so that is a little bit of refactoring. I can do one more. I can actually put this whole gameplay in here. I can do a couple more. So I'm going to say I'm going to play. I'm going to put this in the play function. Now I need to call this play, this whole play function. Or else if I don't call anything, then nothing will be, it'll just jump down here to the end of the game. So remember, functions are not called unless you actually reference their name. This is just defining this function. So I'll show you that. And if I run this, it's going to run all the way from the top, but this gameplay will not be played. It'll just go straight over here to the end of the game, and it'll print out this one because our score is not 50, it's just 0, and it'll just end the game like that. All right, so we need to make the game play. So the last thing that we can do is actually just, we have to write play like this, and then it'll play the game. We can go one more step, and we'll put this end of game in its own function. End of game like this, and we'll put the code in there. All right, and then we can pass it in the score and missed questions because it uses those. Now this one doesn't need to return anything, it's just printing this out. So that is fine. And then we'll just call this function end of game right here. So after it's done its iterations, and it'll just call the end of game function, and we need to pass it the score and missed questions. All right, one other thing that you can do is, you see the score and missed questions, we define them up here. Let's go ahead and move them into the play function like this. So they are only accessible in this function, and then when we pass it to the other functions like this. All right. So now let's just review one more time, and let me zoom out so we can see more of the screen here. So let's see if we can get all of our main logic into view. So what's going to happen here is that Python will execute all of this file, go all the way down here. Nothing is really happening. It's just assigning variables. It's declaring functions. It finally runs the play function. This is the first thing where, where it actually will start printing things out to the screen. It'll run the play function. So it'll, assign our two variables, score and missed questions. And then it will run this. So for I in range n, it will ask the question, get an answer. It will then check the answer and then either update the score or not, and still return the score no matter what. And then after it's looped through all 5 questions, it will run the end of game question, or end of game function, which is this one. So hopefully that makes sense. And let's just play it just to test it out. So I'll say Saturn 50. Let's just get them all right. South Pole, Beijing, first element, hydrogen. All right, so looks good. Congratulations on a perfect score of 50 points. Okay, so we've refactored this. It may not seem actually easier to read at this point, just because our program was so simple, but that is just an example of refactoring. I put every little piece, every little task of our game into a function. So again, we have one for asking the question, one for checking the answer, and another one for the end of game, and finally a last one to just play the entire game. This is all of our game logic, and then we use our user-defined functions in here to go through one at a time and actually execute what we need to. So one benefit of refactoring is that when you get to this like main play function, you get to see what happens without actually looking at the code. So you can see that, all right, we're going to ask the question, we're going to check the answer, and then we're going to run some end of game message. So in that sense, it is a little bit easier to see what is going on. Now, I'd like for you to put in some doc strings over here. I didn't do it just so I could fit all of the code on one string, but when it's done, you should put in some doc strings, and the solution we have does have functions with doc strings. All right, so that is one example of refactoring code.